Hi everyone, this is a review on basic logarithmic and exponential functions. Most of this review is based off evaluating. We have two problems that describe the transformation of a function, and we have two that we solve and one we have to express. So the first ones I'm going to do is just evaluate. So we have, for example, log base 4 of 256. And basically we're looking for the power. If I rewrite this, I have 4 to some power equals 256. Again, this is a review. So your P is 4. Okay, another one we have, let's see. We have log base 6 of 1 over 36. I'm going to rewrite this as log base 6 of 6 to the negative 2, because I can rewrite this as 6 to the negative 2. I'm looking for the power. You can actually see the power right here. It's negative 2. But to get that, we're going to use the power property and bring this negative 2 in front. Log base of a base equals 1, because base to the first power equals your base, any old base. So that goes away, and you have your negative 2. We have, and let's do all the evaluates. We have log base 3 of 1 over 81. So I'm going to write this as log base 3, and 1 over 81 is 3 to the negative 4th. Again, my power is negative 4, so that's your answer. That's our evaluation. But all you do is you move this in front, use your power property. Log base 3 of 3 is 1. So you have negative 4 times 1, which gives you that. And then I think our last one is we have ln, so this is 3. And our last one is ln of 1 over e to the 4th. So this is the same as ln of e to the negative 4. I use my power property and pull this in front. Ln of e equals 1. So that cancels, and my answer is negative 4. Okay? Now, we also have this kind, so we really have one more. We have to evaluate 5 to the power of log base 5 of 11.3. And the answer is going to be 11.3. But a lot of students ask me, how do you get that? So what I'm going to do is set this to the base to the power equals my value. So I'm going to set this to x. Then I'm going to rewrite it as log. So log, the inverse, log base of your value equals your power. So we rewrite this. My base is 5, so I write log base 5 of x equals log my power. My power is right there. Log base 5 of 11.3. And then your answer is right in front of you. X is 11.3, because you can cancel those out. All right, we have 2 where we have to solve. So the solving ones are, I have 2 to the x times 8 to the negative x, that's times, equals 4 to the x. Now what I want to do first is have the same basis. So basically, and this doesn't look like an x, that's an x. So I'm going to change all these to the same base. So it's 2 to the x times 2 cubed, so you have to multiply, that's going to be negative 3x, equals 2 squared, and you multiply that by x. Now I'm going to write this as 2 to the x minus 3x equals 2 to the 2x. Now since my bases are the same, I only have to deal with my exponents. So I have negative 2x equals 2x. And this doesn't make sense because if you divide, you get no solution here. So let's try a different one. Let's try 3 to, let's see, 1/5 to the 2 minus x equals 25. This one is no solution because that doesn't even make sense. Okay, so I'm going to rewrite this with the same base. So this is 5 to the negative 1 times 2 minus x equals 5 squared. Now, I'm going to just solve, since my bases are the same, I have negative 2 plus x equals 2. I add 2 to both sides, so I get x equals 4. Alright, and do I have any more solving? I have one more solving. Okay, so solving, we have log base 7 of x equals 2. So I'm going to rewrite this as the base to some power equals my x. So my base is 7 squared equals my x. So 49 equals x. Okay, the next one we're going to do is express each log in terms of ln of 3. So in terms of and ln of 5. So I'm going to write ln of 25 over 81. Now I'm going to expand this as ln, and I'm going to write this as 5 squared, okay, minus ln of 3 to the 4th. So when I write this, I'm going to move my power up front here. So I have 2 times ln of 5 minus 4 ln of 3. And that's your answer. So you just, it's expressed in terms of ln of 5 and ln of 3. And the last two I have is just basic transformations. So for example, if we have f of x equals e to the x, and then g to the x equals 4e to the x plus 3 plus 6, we're just going to describe this. So the description is going to be, we're going to look at this part first. That's translated three units to the left. Okay, this part here is translated 6 units up. And then this part here is going to be expanded vertically by a factor of 4. All right, and then the last one we have is f of x equals log of x, and g of x is 2 times log of x plus 6. I'm going to talk about this a little one. So basically, this is the green is translated up by 6. And this part here is a expanded vertically by a factor of 2. I just want to put a note here on this right here. If I had this, then this part would have changed, and we would have had translated to the left by 6 units. Okay, so you have to be careful with the logs. If it doesn't have parentheses, it's a shift up and down, and if it's has parentheses here, that's going to be a horizontal shift left and right. Thank you. Have a nice day. Bye-bye.